Hi everyone, welcome back to my channel. In today's video, we are going to use calculus to find the volume of revolution about the x-axis. So before we get started, basically a volume of revolution is basically, I would say, a three-dimensional solid that is formed through a graph. So for example, if I have, let's say I have this graph, right? Let's say a graph that's going like this, looks like, an exponential graph. And if I say I want to find the volume of revolution about the x-axis, what I'm trying to do is basically have this line basically rotate around the x-axis. So when it rotates, right, it will form kind of like a three-dimensional shape, right? And we'll have stacks or layers of shapes that look like cylinders. And so if you kind of visualize it, it rotates about the x-axis. So if this is you look at it from this point of view, you see that this part is kind of like the base of the shape, and here is basically a volume. So essentially what you see, if I put this in a different kind of perspective, is you see kind of like a flask, and the volume is inside. For example, you put water inside, right? So essentially, when I say revolve around the x-axis, you can see that it basically reflects across the x-axis, and if you look at it in a three-dimensional way, it will be formed like a cone-like shape. So that's kind of the basic idea of the volume of revolution. And the general formula that you want to remember is to find the volume, it's pi times the integral from whatever boundary it is, from a to b, and the inside will be the function squared, or this, which is the same as y squared dx. Now this is about the x-axis. If I say about the y-axis, instead it will be dy. But in today's video, we are just focusing on the basics, so revolving about only the x-axis. So now let's try applying that and try doing some practice problems. So I'm just gonna leave the formula here, and I'm just gonna write not another, it's the same thing, but just to be clear, because f of x and y are the exact same thing, so it's the same. So now let's try doing it. So our first question, we see a graph, and it's y equals to 1/2 x plus 4, so it's a linear function. And what we want to do is we want to find the volume of revolution when the shaded region is revolved through 2 pi about the x-axis. So let me just actually shade this, because this is what we actually want to find. So let me just be clear on that. So revolve through 2 pi about the x-axis. So basically, again, what I drew earlier is revolving about the x-axis. So if I look at this visually, it will look something like this, where inside, again, it looks kind of like a cone, similar to what I drew earlier, except that it's a straight line. But the idea is it's revolving around that, so it's like going around and kind of like a cone shaped. So now let's try using our formula and find the volume of revolution. So we have v equals to pi. Now the integral, right, what is our lower bound and upper bound? So it says the shaded region, so it will be the interval on the x-axis. And here I already have, it says clearly that it is 6, and here it's, of course, we can assume it's 0. So it is from 0 to 6 of our function, which is 1 over 2x plus 4. So let's write that down. And remember, we have to square it. So that's our function, or our formula for that. And now we're going to try solving it. So what we want to do is, when we see this kind of situation, what we want to do is we can expand it. So if we were to expand it, right, we get x squared over 4, right, plus 8x over 2 plus 16 dx. So then now that it is fully expanded, we can do the integration. So it's the integral of x squared over 4. That's the same as 1 over 4x squared. So therefore it is x cubed, and 1 over 4 divided by 3 is the same as 1 over 12. And then plus x squared, right? 8 over 2 is the same as 4. So that's 4. So 4 divided by 2 is just 2. And then we have a constant number 16, so that's just 16x. And then remember to always put our lower bound and upper bound in. And once we simplify that, we get 18 plus 72 plus 96. So remember, what I did was I plug in the value 6 in to x, and then subtract 0, where I basically substitute in 0 into the x values, and I get our final value is 186 pi. And remember to always put our units, and in this case it's a volume, so it's units cubed. So there you have it. Let's try another one now. So this time, instead of a linear, we have a quadratic function, y equals to x squared plus 3. Again, we're trying to find the volume of revolution when the shaded region is revolved through 2 pi about the x-axis. So, I already drew the cycle here, but yes, we are trying to revolve about the x-axis. So what it will kind of look like is like this, and then it will have like a shape in there, right? A shape. Again, it kind of looks like a cone, I'd say, a very, very curved cone. So now what we want to do is find the volume of revolution. So it's remember, it's pi times the integral, and what is our boundary? It's 1 to 2. And our function is x squared plus 3, and remember, we have to square the whole thing. So then now let's simplify that. I'm sure by now you kind of get the hang of it. In this case, again, you want to expand it. So if I expand this function, I get x fourth plus 6x squared plus 9. And then now I could integrate it. So I get 1 over 5 x to the power 5 plus x cubed. 6 divided by 3 is 2 plus 9x. And then my next step is to plug in 2 in. So if I were to plug in 2, I get 32 over 5 plus 16 plus 18. And then now my next step is to plug in 1 into the x values and subtract it. So subtract 1 over 5 plus 2 plus 9. And then now, once I've simplified all that, I get 146 over 5 pi units cubed. So there you have it. The calculation is a little bit heavy, but the main idea is basically how to find the volume of revolution. So remember, when it says about the x-axis, it's basically rotating about the x-axis, where you see that For example, in the first question, we see that it's a linear function, and basically we drew an extra line below the x-axis to just visualize that it will be, going around. So it will look kind of like a cone shaped. And the formula, remember, is pi times the integral from a to b y squared, or f of x squared, same thing. But yes, that's the main idea. So I hope you guys enjoyed this video and hope it's a good kind of summary of volume of revolution, and thank you for watching.